Hi, everybody. Welcome to another Salty seminar. This will be the last for the season, so we're getting prepared to go outside and do field work. So we're really glad to have everybody joining us today. Today we're going to go back in time and explore Great Salt Lake through the lens of history. These histories are told by scientists that study rocks, archaeological evidence, and even bird remains preserved along the shores of our lake. And so tonight we're going to hear from Dr. Jack Oviatt. He's a Lake Bonneville geologist, and we'll talk about the history of the Great Salt Lake Basin on a million-year time scale. And this is all told in scraps of available geologic information, including evidence from sediment cores. We'll hear from I hope I can call her Dr. Allison Wolfe, a paleozoologist at the University of Utah. She will describe the dynamics of Great Salt Lake bird populations through time, as told through 13,000-year-old owl pellets excavated from the cave near the lake. And then Dr. Chris Merritt, he's the State Historic Preservation Officer, will bring us to the human side of history by exploring how ancient people relied on the resources of Great Salt Lake. And we can kind of put this all together into these histories that provide evidence of our future and the future of Great Salt Lake. So I'm really excited. We did partner with the Utah State Office of Historic Preservation, SHPO, I think I got that right, to do this. It's part of their Archaeology Month. We are one day late, but we did not want to intrude on your Memorial Day. So we hope you had a really great weekend. Today, like all of our Salty seminars, everything is recorded and it's put on our YouTube channel. At the bottom of this screen, it says there's a QR code with links and resources. You can take a picture of it and it will take you right to a Google document with a whole bunch of resources that you can link to, readings, books. All of the links that go into the chat today will be in there. I highly recommend that you go and listen to the Salty Shorts. It's a new series that we're doing. We hope that it inspires you to get your short salty by listening to these short, half an hour to an hour long events. We talked with Emily Lewis about water law and water banking. She is an attorney a water attorney with Clyde Snow. And it was a really awesome conversation that we really need to be thinking about. This year, we saw, very low snowpack. There's not going to be a lot of runoff. Our lake is already very low, and we really need to be looking at what is going on with Great Salt Lake and creative solutions to getting water to the lake. This is our YouTube channel. Again, there's a QR code that you can link to. I use playlists. So if you click on playlists, you can see all of the videos are organized according to different topics like spiral jetty, dust, shrinking lake. And so you can go and watch all of those. The videos and recordings from today will be put up by tonight. So you can watch those whenever you want. This is my cute little Artie the brine shrimp finger puppet, telling you that there are two ways to interact with us tonight. There's a chat function. Hopefully in the chat function, what we're going to mostly see is just that chat, commenting. I'll put links in there, any comments, or if you want to say hi to people, go ahead and do that. And then there's a question and answer function. That's where we would love to hold your questions. We're going to have a question session at the end of this seminar, and that helps us organize and keep track of all of the questions. Great. And so I think that we should just start this off. We are really stoked today to have Dr. Jack Oviatt. He received his bachelor's and master's degree in geology from the University of Wyoming in the 1970s, and then came to Salt Lake City to work on glacial geomorphology with Don Curry at the University of Utah. Quickly, his research interests switched to Lake Bonneville, And he recently wrote, co-edited a book on Lake Bonneville that I will link to also. And also while he was in Salt Lake as a student, he worked for the Division of State History, the U.S. Geological Survey, and the Utah Geological Survey. So he has a long history with Great Salt Lake in Utah and continues to work on the geomorphology, stratigraphy, and geologic history of Lake Bonneville and Great Salt Lake. And we sure appreciate all of Jack's help whenever we have a question or need to direct somebody. Jack is always so awesome to answer all of our questions. So Jack, please join us today. Thank you for coming.
Thank you, Jamie. Let me see if I can figure out how to do the share screen.
Okay.
All right, did that work?
Yeah, that worked. It's great.
All right.
Yeah, that looks great, Jack. Thank you.
All right. Let's just dive into this. Let's see. I'm trying to, I have all these images on the right side that, okay, I can move them out of the way here.
And just so you know, all I see is your presentation.
Okay. But
But you can't.
I can't see it all, so but that's okay. All right, there's the title page.
If you just push your forward keys, we'll see your next slide. There you go.
Okay, got it. All right, so we'll start out talking about the origin of the basin, and then say a little bit about, so the basin is there because of tectonics, and the lakes come and go because the climate changes through time. And so I got this this phrase from Genevieve, who always talks about how important tectonics is, and it really is important. But of course, it's on a very long time scale. It's on its importance is something that that we understand on a time scale that's longer than human time. And most of you probably already know this, but in the Great Basin, or in the Basin and Range province, the Basin and Range province is there because the crust is extending. It's being pulled apart from tectonic forces, and so it's extending. It's spreading apart. So the Sierra Nevada is slowly getting farther away from the Wasatch Range, and in between there are a whole series of mountain ranges and basins. Mountain ranges that generally run north-south through the mostly across the state of Nevada, but Western Utah is also in the Great Basin, or the Basin and Range province. And these I don't know if you can see on the right-hand side, there are a couple of cross sections that are borrowed from Genevieve. The upper one shows the extension separating the Wasatch Range from the Sierra Nevada, and then the multiple mountain ranges and basins in between. And then the lower block diagram shows just a small part of the Basin and Range province, with the Wasatch Range in the background and Antelope Island and Great Salt Lake in the foreground. And what you can't see on the ground when you're out there floating on the lake or whatever are all the faults in the subsurface. And we don't know the exact placement of all those faults, but we have a pretty good idea of where they are and how they're moving through time. Most of this deformation occurred millions of years ago, but some of it is still going on. In other words, some of the the moraines that have been deposited by glaciers in the Wasatch Range just 20,000 years ago are cut by the Wasatch Fault or splays of the Wasatch Fault. And we can see those fault scarps right now in places like the G.K. Gilbert Park down at the mouth of Little Cottonwood Canyon. And some of those scarps formed just a few thousand years ago. So that kind of deformation is still going on locally. But most of the basins that we know of today, including the Great Salt Lake Basin, started forming 20 or 15 million years ago. And the basin was already in place even a couple of million years ago. And that's important for understanding the lake history. The basin was there long before the lake started to appear. So let's talk a little bit about the climate. So the basin formed because of the tectonics, but the climate was responsible for producing lakes or periods when the lakes are not very well represented. The Great Salt Lake is a closed basin lake. So that means that all the water that flows into the lake has to exit by evaporation or maybe by groundwater in some cases, but not so much in the case of Great Salt Lake. But there's no outflowing river. So that little term at the right-hand side of the red equation there that says delta S means a change in storage. So you can think of the storage as the volume of water in the lake that changes through time depending on whether the inputs of water are greater than the outputs or vice versa. So it's the size of the lake or the volume of the lake which is dependent on the climate, either the inputs, both the inputs and the outputs and how they compare to each other. In the case of Great Salt Lake, right now in the modern situation, there's groundwater flowing into the lake, but we're not aware of any groundwater flowing out of the lake at the present time. When the lake system was really large, when Lake Bonneville was here, in other words, the lake got high enough that some of the groundwater, some of the lake water started to leak out through the groundwater system. But that doesn't happen when the lake is very low. Here's kind of a summary of the chronology of Lake Bonneville and Great Salt Lake as we know it now. So this is just the last 30,000 years. So that, one of the things we need to get used to is the difference between the geologic perspective on time and the human perspective on time. So I say just 30,000 years. Well, 30,000 years is an incredibly long time on a human time scale, but on a geologic time scale, it's very, very short. But a lot has happened in the last 30,000 years, of course. Lake Bonneville came and went, and it dropped down to very low levels, similar to what we're seeing now, about 13,000 years ago. Then about, little over 11,000 years ago, say 11,500 years ago, the Great Salt Lake rose up probably very rapidly, but something like 50 feet higher than the modern average in this event called the Gilbert episode. But it didn't last very long. It just rose up, and within a few years, it was back down to average levels. And we know from some work in the Locomotive Springs area up at the north end of Great Salt Lake that the lake rose up to about 4230 feet, which is about 1289 meters. sometime a little bit after 10 or 11,000 years ago. But other than those two events, the Great Salt Lake has stayed within a fairly narrow elevation range for the last 13,000 years. And that's shown by that gray bar outlined by dashed lines on the right-hand side of the diagram. All right, so if we just pick out the historic part of that record, which really at that time scale on the previous slide doesn't really show up. But just since the mid 1800s, the Great Salt Lake level has gone up and down a lot. It's a very jagged, very spiky kind of record. Generally declining, probably because of the use of water by humans before it even gets to the lake. But no, we don't need to worry so much about the long-term decline as the up and down nature of the closed basin lake system. And that's probably what you would have seen in the long-term geologic record as well. It was a closed basin lake for most of its history. And so it was always going up and down. Here's a question that I frequently am asked, or people just assume that the lake did dry up at various times in the past and that it might dry up again. We know from the geologic record that I'll just read this: wetlands came and went more than once in geologic time, what's now the bottom of the Great Salt Lake, but no evidence has been found of the mud ever being completely dry. So in other words, if there were wetlands out on the bottom of the lake, what is the bottom now, it means that there was fresh water entering the system in order for the wetlands to exist. And this was probably fresh water from rivers coming into the system, like the Bear River or the Weaver or the Jordan River, or groundwater discharge out on the floor of what's now the floor of the lake. But as far as we know, it never completely dried up. There was always some water entering the system. And I put this together several years ago, just an attempt to show what we know about the elevations of shorelines of Lake Bonneville. So you'll recognize names like the Bonneville shoreline and the Provo shoreline, Stansbury shoreline, and down lower the Great Salt Lake and the Gilbert. Those are all part of the system, the very late, late Pleistocene and Holocene lakes that we know of in the system. And we can see those shorelines, the Bonneville and the Provo and Stansbury, very clearly marked on the mountainsides around the basin. But they really obscure the older shorelines. So like in the middle there, it says LV 1490, that's meters, and 150,000, that's 150,000 years ago. So LV stands for Little Valley. So that's the Little Valley Lake cycle. As far as we know, the Little Valley Lake rose up to higher than the much later, the Provo shoreline of Lake Bonneville. Provo shoreline, of course, didn't exist at that time when the Little Valley Lake was there. But the Little Valley Lake was a pretty large lake. It was not quite as high as Lake Bonneville, but higher than the Provo shoreline. And the other lake that we have an estimate of for its maximum elevation is the Cutler Dam Lake, which rose to about 1340 meters about 60,000 years ago. So this just gives an idea of the heights of those lakes, the few lake cycles that we know about in pre-Bonneville time. And by the way, the Bonneville and Provo shorelines are marked with gray bars because the elevations of the shorelines vary depending on where you are in the basin. That's because of isostatic rebound of the lake basin after the Bonneville water load was removed, after it evaporated away. So there's a range of elevations for those two shorelines. There's actually a range for Stansbury, but we don't know that very well, so it's not marked on there. And it's likely that both the Little Valley and Cutler Dam lakes had some effect on the isostasy of the basin. So in other words, if we had a more complete record of how high those shorelines were, we would probably find a range of values similar to what we see for the Bonneville and Provo. But we just don't have enough information to show that on this diagram. Now I want to talk a little bit about how we know some of the information about the geologic history of the basin. And a lot of it comes from these core records. These are sediment cores, and one of the most important ones is called the Burmester core. It was taken in 1970 by a professor at the University of Utah. His name was A.J. Erdley, and it was a long core. It went down to just over 1,000 feet, or just over 300 meters in depth. And the oldest sediments down at the bottom of the core are maybe 3.5 million years old. This is, as far as cores go from the Great Salt Lake Basin, this is probably the longest one. There are drill holes that oil companies drilled in Great Salt Lake that are deeper than that, but they didn't take cores. So the Burmester core is really a good one, and it still exists. Even though it was taken in 1970, it's still around. It's now archived at the Utah Geological Survey at the Core Center, but before that it was at the University of Utah for many years. And it was just sort of buried down in the basement, and nobody really paid any attention to it, except for people like me who are just kind of crazy and want to see some of the old evidence. But so if you talk to the right people, you could go to the University of Utah and dig out the old core boxes and look at the core. The Burmester core was taken just south of the Burmester sighting. So in 1970, the interstate highway, I'm not sure if it had been completed yet at that point in 1970, but the railroad went along there. It still does. And there was a railroad sighting. It was called Burmester, probably because it was close by a little settlement called Burmester. So the core was taken in that area somewhere. Notice that it was just south of Great Salt Lake, not in the lake. It was up on land, but still a fairly low elevation. So because of its low elevation in the basin, it was presumed by Erdley and others to contain a good record of the lakes as they came and went in the basin. I just threw this in. This is an image of a core from Clear Lake in California. I just threw it in because even though the Burmester core is old and all dried out, it doesn't look like this anymore, but it still gives an example of what a core does look like when it's pristine before it is dried out. You can see that there are lots of laminated intervals in there, and whatever else is present in the details of the sedimentology. But anyway, if you keep track of these changes and mark them down and look for ways of dating things like volcanic ashes or materials that can be dated by radiocarbon or whatever is available. You can learn a lot about the depositional environments and how they changed through time by studying the core. So it turns out I don't have a picture of the Burmester core, or I would show you its poor condition because it's all dried out and broken up, but it still has lots of useful information in it. And one of those is that by studying the sediments, we can see that there are a lot of buried soils present. Well, that's important because a soil, of course, forms when the lake is not present and the land is exposed to the atmosphere. So if a soil is present, that means that the time is represented by the soil formation and not by lake deposition. It turns out that the Burmester core does contain a lot of these soils. So it means that the sedimentation from the lake was discontinuous or intermittent, and that each soil represents a period of non-deposition, and geologists call that an unconformity. So by studying the Burmester core, you can learn a lot about these paleo lakes. You can't really see in the Burmester core, you don't have sediments of very low lakes because, of course, it was the Burmester core site was up above the lake level. But there are lots of these buried soils and lots of intervals of deep lake sedimentation. So on this diagram, I've tried to show age on the horizontal axis and elevation. Let's see, I've got meters on the left and feet on the right. So just for reference, like the B stands for Lake Bonneville. Bonneville was the largest lake, the highest lake in the basin, and the sediments of Lake Bonneville are present in the Burmester core. Then the other ones are CD stands for Cutler Dam, LV for Little Valley, PP for Pokes Point, LC for Lava Creek, and then the U's are for unnamed lake cycles. But I think this is interesting because it shows that each deep lake cycle was a very short-lived event on a geologic timescale anyway. By short-lived, I mean like 17,000 years. So that's an incredibly long time on a human timescale, but very short on a geologic timescale. So each of the deep lake cycles was something on the order of 15 to 20,000 years in length, but that's really not more than the width of the line, the vertical black lines that show the lake cycles. And in between those times, the lake level was low. It probably looked a lot like what we see now for modern Great Salt Lake. Let's see, the next slide has a little bit of ideas about Great Salt Lake from a geologic time perspective. Just means a very low lake without being specific about the lake level or the elevation of the lake. So I have some bulleted items there. Great Salt Lake has been around for a long, long time, for millions of years. But of course, it's a closed basin lake, so that the lake level keeps changing. And it's not like it's just a constant level. We know that just in the last few years, the lake level has been declining because of the climate and also because humans are taking so much water out of the system. But on a geologic timescale, of course, humans weren't really around until the last, since the very late Pleistocene into the Holocene. But the climate kept changing all the time. So we could think of a lake even as high as 4,265 feet or roughly 1,300 meters as being essentially a Great Salt Lake equivalent. And if the lake did get that high, it would flood out into the Great Salt Lake Basin or into the Great Salt Lake Desert. And you've all seen this, but there's a Google Earth image that shows the Great Salt Lake and then the Great Salt Lake Desert off to the west. And I've been working with Don Clark and from the Utah Geological Survey, and Jeremiah Burno and Brenda Bowen and other people from the University of Utah who are really focusing on the Bonneville salt flats on the western part of the Great Salt Lake Desert. But all over, we're interested in all of the Great Salt Lake Desert and the mud flats out there. That you've probably driven across I-80 and you know how flat it is out there. Well, that Great Salt Lake Desert mud flats extends for many, many miles off to the north and many miles off to the south. And I just want to say a little bit about one of the cores that we took in our studies of the Great Salt Lake Desert. Don Clark supervised this, but this core called BC2, there's a picture of it on the left. And then a couple of microscope views of the different kinds of sediments that we found in that core and lots of other cores from the sediments in the Great Salt Lake. We find ostracods, which are microscopic crustaceans, and they are preserved as fossils. Ostracods of the genus species Limnocythera staplani as being very common in some layers of those sediments. And other layers, you get these rod-shaped dewoods, which are in the view in the bottom photomicrograph. Rod-shaped dewoods, we think, are formed around brine shrimp fecal pellets. So if you see rod-shaped dewoods present in the sediments, it means brine shrimp were living there at some time in the past, and then they got preserved. The ooids got preserved in the sediments. So it turns out that Limnocythera staplani only lives in well, it does live into fresh, but usually it's found in brackish or saline water. But if the water gets too saline, then it can't live anymore, and brine shrimp start to appear. So in a case where you have sediment dominated by spherical ooids, then you know that that was probably a shallow but very hypersaline lake for the brine shrimp to live there. But in other layers, if you find no brine shrimp fecal pellets or spherical ooids, but you do find lots of the Limnocythera staplani, it means that the lake was a little bit bigger, and so it wasn't quite as salty, but still probably at least brackish for the ostracods to live and be happy. Well, what happens in the future? Well, I dug up this diagram from a published paper from almost 20 years ago now. And on the diagram, it shows the time with 0 in the middle there, the left center, 0 being modern day, and then older time going to the right and younger going to the left. And let's see, I can't see the scale very well. So I'm gonna move it over here. So this is in thousands of years before present are marked with the negative signs, and then thousands of years off into the future are marked with positive 50 and 100. So in other words, we can see the curve varying through time in going back into geologic time back to 200,000 years ago. And this is a curve that shows ice volume. This is global ice volume. And notice that the scale is inverted. So as the line goes down, it means there's more ice volume present on Earth. That means more glacial ice. So like I've inserted the letters like B for Bonneville, CD for Cutler Dam, GSL for Great Salt Lake, LV for Little Valley, and so forth. And these are kind of inferred because this is not a lake level curve. This is a change. This showing change in ice volume on a global scale. But you can pick out the periods of glaciation. A big one was when Lake Bonneville existed about 20,000 years ago. And another big one was when the Little Valley Lake existed. And in between, you see these times when the curve goes way up to the top of the diagram. And those are times when there's very little ice volume present on Earth. And that's when Great Salt Lake or its equivalent are present in the basin. But then looking at the left-hand side of the diagram, it goes off into the future. And it looks like about 50,000 years from now will be sort of the end of the present interglacial that we're living in. And excuse me. Presumably, Great Salt Lake, if it's not being influenced by humans and our addition of CO2 to the atmosphere, 50,000 years from now, Great Salt Lake might start to rise again, and then maybe 100,000 years ago, we'll have something similar to Lake Bonneville in the basin. The other two curves at the top are June insolation at 65 degrees north. That is how much solar radiation is coming in. We don't really need to, and I should have probably cut those off for the purposes of this talk, but it gives some explanation for where the ice volume curve came from. So there's a pretty brief overview of something about the past geologic history of the Lake Basin and a little bit about what might happen in the future. So thanks for listening.
Thanks, Jack. Hey, I do have one question. I know I'm not supposed to ask them until the end, but do you think is Great Salt Lake a remnant of Lake Bonneville? This is something I read about a lot, that Great Salt Lake is a remnant of Lake Bonneville.
Well, you see that in, let's see, can we, I don't know how to do this. Let's go back to this diagram. And you see the vertical line for Lake Bonneville, and then there's just a tiny little sliver of time that we're living in after Lake Bonneville disappeared. But after each one of those major lake cycles, there was a very long period when the lake was probably similar to what we're seeing now. So if you look at it from a long-term perspective, you probably wouldn't call what we're having now as a remnant, Great Salt Lake as a remnant of Lake Bonneville. We're just a step in time. And
yeah, that's
so
something.
It's tempting to, on a human time scale, it certainly makes sense to think of it as a remnant. On a geologic time scale, no, it doesn't really make sense.
Thank you. Thank you, Jack, so much.
Okay, so let's see, I need to get out of this, right?
If you just stop sharing, there should be a little red button that says stop share.
Oh, stop here. Yeah, okay. Got it.
Awesome. Oh, that's so interesting. I can't wait to hear all of the questions. Our next speaker is going to speak about this really cool place on this planet in our Great Salt Lake. In Lake Bonneville times, it definitely would have been covered in the West Desert. And you're looking at a map of this place called the Utah Test and Training Range. And I call it the bombing range. It's kind of like a little euphemism that we use for it. And I want you to notice that this Utah Test and Training Range actually goes clear into Great Salt Lake. I've heard they did that because of water levels, because they knew that water levels would come and go, and they didn't want people to be able to just walk up the shoreline to access this Utah Test and Training Range. And I mean, this is the place where you see planes flying from Hill Air Force Base and into the West Desert to test ammunitions. When I first met this place, I was in college. I was helping a graduate student at Utah State University write about the biodiversity of the bombing range. Later, I met this place when I would be out on boats with either the brine shrimp industry or with the Division of Wildlife Resources. And we were really studying the brine shrimp. But while we were studying these shrimp, we would see these planes fly overhead and leave these like very powerful bombs. I mean, even when we were underway on a boat on this dense Great Salt Lake water, we could feel the impact from the bombs that were going off in this testing range. And I envisioned this place, this bombing range, as this post-apocalyptic place with mutated zombies and bombs jutting out of every inch of the land, you know, like on Wile E. Coyote, and you see the bomb with the little propeller, you know, I envision this place. But the cool thing is all of this place, I mean, it's over like 1 million acres. And hopefully we will have somebody on Salty Science here soon, but it's a very large place that's all behind a fence, and it's all protected with this fence and these military police that if you go out there, I mean, you're not unnoticed. The military police do come and will kick you off of that land because there is very sensitive information out there. It turns out that the bombing range is very biodiverse because of this fence. And the cool thing is that not only does it protect wildlife, it also protects cultural resources. So last week, the Utah State Historic Preservation Office put on a talk about the cultural history, the archaeology and preservation of Utah's military installations. And I want to play just a short piece from that right now because it's such a great segue into our next panelist.
Range and talk about some of our unique resources there. We manage about 1 million acres of land out on the Utah Test and Training Range, and that's out in the West Desert. So for those of you here in Utah, whenever you hear the jets heading out west, that's where they're headed to do their training. And these resources include the earliest remnants of man on the range that date to approximately 12,000 years ago, through Cold War era historic targets. So we have quite a wide history that we're managing on the range. We also do have historic buildings such as the picture in the upper right, which is a rocket motor testing facility that dates to the Cold War. And one of the really unique and wonderful things about the military ranges specifically is because we've used them for so long for testing, and with that use comes a fence line. Most people don't want to cross over, a lot of warning signs, all those types of things. These resources are protected in ways that they wouldn't be if they were more open to the public. And so we've been able to find very unique resources out on that range. And if you look down at the bottom right, there's a picture, and one of the resources we found recently within the last 5 or so years was open pit. And in fact, the earliest open pit fire site that has been found in the Great Basin. It dates to, again, a little over 12,000 years ago, and it included everything from just the fact that there was a hearth site there, but it also included a huge amount of bird bone, different types of fowl, as well as tobacco seeds. And so we're still, there's still some work being done on that, but there's also some papers and some things that have come out concerning that because it's such a unique site. We are also in the same region this was found. If you look at that lovely point there in the center, which is a Haskett point, that's in fact the largest Haskett point ever found. And we found a modified version of a modified Haskett found nearby this hearth pit. And so it gave us an opportunity, and our researchers an opportunity to get a date on these Haskett points and really get a firm date on that, because we had one found at the same level as the hearth site was found. And that area is very unique in that we've found so many of these Haskett points in one 5,000 acre survey alone. We found over, or I say we, our wonderful contractors, found over 50 of these Haskett points alone. And so we've got a really unique landscape out there called the Old Riverbed Delta. And that's where a lot of these are being found. And the delta was formed as Lake Bonneville was receding, and it became a big marshland. And we still have remnants of these channels from the delta and such out there. And it's along there that we're finding some of this really interesting, really unique archaeological sites. And so that's one of the things that we're still really exploring and getting a better handle of exactly how much and what is out there. And in fact, we are hoping to do some data recovery on another fire pit site that we've recently, that was found just a couple of years after the site that was excavated that's shown here. And so that's one area, but we also house different types of prehistoric sites, such as the rock rings. We have a whole hillside of these rock rings up there. We do have some rock art out there, as well as a lot of cave and rock shelter sites that are considered significant and some sacred to the local tribes. So that's kind of a brief overview of a lot of the resources that we do protect, manage, and really oversee out on the Utah Test and Training Range. So I'll pass it to Maya to talk about some of the Utah National Guard.
Cool. There's just tons of cool stuff in our state, right? I mean, this is like such a weird place to think about, you know, dropping bombs on, but being very biodiverse and really preserving cultural sites. And so I'm really excited to bring our next person. Allison Wolfe is a PhD candidate in the anthropology department at the University of Utah. I heard that she is defending in 2 weeks. So I just want to share my appreciation with Allison for coming to do this right before she defends. She's trained as an archaeologist specializing in zooarchaeology, which is the study of animal remains in archaeological contexts. She considers herself more of a paleozoologist as she works with paleontological materials as well. Her research revolves around investigating past relationships between animals, the environment, and humans, and using that information to inform modern day conservation. So please come and join us, Allison. Thank you for coming.
Thank you for that. Let's see if I can get this to work here. Okay. Can you see that?
It looks great.
Presentation. All right.
Yep.
Awesome. Yeah, so you just heard a little bit about the test and training range, which is where this cave is located, Homestead Cave. But before I get to Homestead Cave, I want to first back up and talk more broadly about birds in Great Salt Lake. So during his landmark survey of Great Salt Lake in 1849, Howard Stansbury wrote, quote, "The Salt Lake, which lay about half a mile to the eastward, was covered by immense flocks of wild geese and ducks. Never did I behold anything like the immense numbers here congregated together. Thousands of acres, as far as the eye could reach, seemed literally covered with them, presenting a scene of busy, animated cheerfulness in most graceful contrast with the dreary, silent solitude by which we were immediately surrounded." So Great Salt Lake hosts an unparalleled menagerie of bird life that attracts birders from all over the world. The lake and its extensive wetlands function as resting and staging areas for millions of migratory birds every year, including grebes, shorebirds, and waterfowl. And the 9 major islands across the lake provide nesting areas for birds such as pelicans, cormorants, and gulls away from terrestrial predators. And although the lake today doesn't support fish, there's an ample supply of brine shrimp and brine flies that many of these birds depend on. But what many don't realize is that the rich avifauna that we see at Great Salt Lake today owes its existence to the long history of environmental change in this area. So as you heard from Dr. Oviatt earlier, oh, sorry, I missed a slide here. Here are some of the important birds of Great Salt Lake. So as you heard from Dr. Oviatt just a few minutes ago, Great Salt Lake is, for my time scale, a remnant of Lake Bonneville that once occupied the eastern Great Basin. So outlined here in white, this is the final high stand of Great Salt Lake during the Gilbert episode, which I'll talk about in a second. And then this hashed area is modern Great Salt Lake. So Lake Bonneville had its final regression at the end of the Pleistocene about 13,000 years ago. And since then, in the ensuing 13,000 years, the Bonneville Basin has experienced a wide range of environmental changes, including changes in seasonality, temperature, moisture, which resulted in substantial biotic change through time. And recent studies have demonstrated how different biotic groups, such as plants, fishes, mammals, responded to these changes, but missing from this list is birds. So despite the presence of avifaunal remains, avifaunal, ave meaning bird, faunal meaning animal, so avifaunal remains in a number of sites across the Bonneville Basin, these remains have been largely understudied and underreported. And so we don't know a lot about how bird populations responded to environmental change in the past in the Bonneville Basin. So that was kind of the impetus for my dissertation research, is I wanted to look at how bird populations responded to different environmental changes through time. And luckily enough, there was a site in the Bonneville Basin, which you've already heard a little bit about, that has a substantial avifaunal record, and that's Homestead Cave. So that's where it is in relation to Great Salt Lake. So it's located, there's the opening of the cave. It's located just west of Great Salt Lake in the Lakeside Mountains on what is now the Utah Test and Training Range. And it was underwater until Lake Bonneville's final regression 13,000 years ago. So this cave was excavated by Madsen et al. In 1993 and 1994. They were going around the Bonneville Basin looking for sites that could provide long environmental records in the basin. They found this one. They excavated a 1 by 1 meter column sample. They went down 2.7 meters to bedrock, and they took out material in 18 well-defined strata or layers. And while they found a few archaeological remains in the sample, especially towards the top, what they actually uncovered was tens of thousands of small bones, just like you see in this picture here. And that's because it turns out this cave has been home to raptors, most likely large owls, like great horned owls, like this one pictured here. This one was in my backyard a while ago. And it's a really long and continuous record. So sorry, I lost my spot. Okay, so great horned owls have been roosting in this cave for 13,000 years. So they've been sitting there spitting up their pellets, which contain all the undigestible fur and feathers, and most importantly for me, bones, of all the things that they've been eating. So what we're left with is a 13,000 year record of what these owls have been eating. So as a result, this cave contains one of the most fine-grained and well-dated records of small vertebrates in all of Western North America. And it's a really great record because it's limited to a very local fauna. Since it was collected by owls, they don't go very far from their roost. So it's limited to a very small geographic area. And it's a really long and continuous record. So radiocarbon dates show that it was sorry, my dogs. Zoom life. So it's a long and continuous record. Radiocarbon dates show that it was deposited sequentially from 13,100 to 700 years ago. And during this time span, the Bonneville Basin experienced a lot of dramatic environmental changes. So the Homestead Cave assemblage offers a unique opportunity to investigate biotic change in the Bonneville Basin. And the fish and small mammal records from the cave have been studied and reported, and the trends detected in those records, along with the abundant paleovegetation and lake level data that we have for the basin, allow for the generation of testable predictions of avifaunal change. So I'm working on identifying the bird bones from the cave to investigate how the relative abundance of different bird taxa changed through time, along with different environmental changes. Now, this is still a work in progress. It's a really long record with tens of thousands of bones. So as you can imagine, it takes a while to get through. So eventually I'll have the 13,000 year record, but for now, I just want to demonstrate this with data from the first 5 strata of Homestead Cave. And these strata span almost 6,000 years from the beginning of the assemblage 13,100 years ago through the early Holocene to about 7,500 years ago. And this period covers some of the most conspicuous environmental changes in the Bonneville Basin's history, including the final regression of Lake Bonneville. So, like I said, I use other records from Homestead Cave and from the Bonneville Basin in general to make predictions about what the bird fauna should be doing. So we know from lake level records, which you just heard a lot about from Dr. Oviatt, that Lake Bonneville dropped to elevations similar to modern Great Salt Lake levels around 13,000 years ago. So this is really low relative to the huge freshwater lake that it was before. So at this point, the lake is low, the water is saltier, it's warmer, and there are more mud flats and wetlands around the lake. And it stayed at this low level for about 1,400 years, becoming increasingly warm and brackish until the lake level rose a little bit around 11,600 years ago. And the water became a little bit cooler and a little bit less salty. And this is what we refer to as the Gilbert episode. But soon after that, it didn't stay like that for long. Soon after that, it regressed again, getting close to modern Great Salt Lake levels, and it became hypersaline. The marshy areas around the lake increased and remained this way for the rest of the record that I'm looking at here. So to correlate this with the Homestead record, this is the very beginning of the record, so the deepest layers are strata. So stratum 1 spans the very end of the final regression and the brackish low lake level, and then stratum 2 captures a little bit of this brief rise, and then strata 3 through 5 cover the early Holocene hypersaline Great Salt Lake. So the fish record from Homestead Cave can also give us an idea of what was going on and help inform our predictions of what the bird fauna should be doing. So during stratum 1, when the lake level is getting warmer and saltier, there were a series of fish die-off events, which is how fish ended up in the cave. They died and washed up on shore, and the owls scavenged them and then spit up their bones in the cave. And then the fish at the end of stratum 1 are smaller in size and they contain more species that are tolerant of higher salinities and warmer temperatures. And then in stratum 2, fish recolonized the lake briefly during this episode, but again, it was smaller fish, more salinity and temperature tolerant taxa, and then they died off again when the lake became hypersaline and were eventually replaced by brine shrimp and brine flies. So based on the trends established by these different records, so in this case, the lake level records and the fish records, we can generate testable predictions of how bird fauna changed through this time. And so my prediction for this period is pretty straightforward. So insofar as lake levels decreased at the beginning of this record, resulting in an increase in water salinity and water temperature, fish dying off, being replaced by brine shrimp, and marsh and mudflat habitats increased, we would expect proportionate declines in certain taxa that depend on deeper water and fish relative to those who prefer shallow water and wetlands and eat a lot of more brine shrimp and brine flies. So the relative abundance of deeper water taxa should decline and then should remain low throughout the rest of this record. So I tested this by looking at 3 different groupings of birds, from really broad groups to a little more specific. So first I looked at the change in the abundance of deep water birds versus shallow water birds. So deep water birds are birds that are more carnivorous. They tend to be diving taxa that occur in higher abundances in deeper water habitats with abundant fish and aquatic invertebrates. So these include things like diving ducks, western and Clark's grebes, cormorants, and loons. And shallow water birds are taxa that are more omnivorous. They use higher proportions of aquatic vegetation and are thus more abundant in brackish, shallow water, mudflat, and marsh habitats. So these include things like geese, dabbling ducks, eared and horned grebes, rails and coots, shorebirds, gulls, species like that. So the second category is a little bit more narrow, and I was focusing on ducks. So I looked at diving ducks versus dabbling ducks. So diving ducks are more piscivorous, and they dive to get their food. So these include ducks like mergansers, for example, and they prefer deeper water habitats. Dabbling ducks like mallards, for example, they eat only plants and invertebrates, and they get those by tipping their front side into the water. So they prefer more shallow water habitats. And then the final category I looked at focused on grebes. And so it involved 2 types of grebes. Ecmophorous grebes include western and Clark's grebes. Those are the bigger black and white grebes. They're specialist piscivores, so they dive to get their fish. And then podiceps grebes are the smaller eared and horned grebes, and they eat more plants and aquatic invertebrates, and they especially like brine shrimp and brine flies. So for all 3 of these categories, skipping ahead, we should expect a decline in the deeper water taxa, so the ones on the left, versus the more shallow water taxa from stratum 1 into stratum 2. And then the deeper water taxa should remain relatively low throughout the rest of the sequence through stratum 5. And so that is what we see across all 5 strata for all of these groupings. So here's the broadest deep water index. You see this statistically significant decline from stratum 1 into stratum 2, and then it remains low. Same thing kind of for the ducks. There is a statistically significant decline from stratum 1 into stratum 2, and it keeps declining. There's this increase here, which I'm not super sure why that happens. It is not statistically significant and doesn't reach quite as high as we see in stratum 1. It may just have to do with the fact that the lake is a really good stopover point for migratory waterfowl. But it does decline significantly here when the lake becomes, when the lake level drops significantly. And then the grebe index as well, we see a decrease, significant decrease here, and then it remains low. So we see in all three of these groups that I was looking at a statistically significant decrease from stratum 1 to stratum 2, which, as you'll remember, is when the lake experienced its final regression and then became hypersaline. So that all seems super straightforward and common sense, right? Like anyone could have guessed that when the lake shrinks and fish die out, that diving and fish-eating birds should decrease in number. So what's the point? Like, why does this kind of thing matter? It seems really obvious that we should see these trends. Well, while that example that I just went through involves a really big change with common sense effects, it establishes that the Homestead avifaunal record does register environmental effects on bird taxa. And that's really exciting because it shows that we can use this long, detailed record from Homestead Cave, along with existing paleoenvironmental records and even paleoclimatological models, to describe and ultimately predict avifaunal responses to environmental changes. And this can include responses to big changes like this lake level drop, or responses to smaller, more nuanced changes like increased seasonality or decreased precipitation. And this is invaluable data for conservation. So right now, wildlife management and conservation decisions are usually formulated on the basis of historic data. But these data span less than 200 years. And that's problematic because during historic times, human activities were already severely impacting bird habitats and bird populations. And 200 years represents a relatively short period that doesn't capture the full range of environmental variation that birds have experienced in the past and are predicted to endure in the future due to impending climate change. So these data that I have from Homestead Cave are thus valuable for their ability to predict or to provide long-term local records that span such environmental variation. So to give you an example of this, I want to talk about this bird for a second, greater sage grouse, which is probably not the first bird you think of when you think about Great Salt Lake, and that's probably because they don't occur in this area today, but they are actually well represented in the Homestead record. So they were around in the prehistoric past, even though they're not there today. The conservation of greater sage grouse is a really big issue in the West today. Since the mid-20th century, the abundance and distributional range of this bird has declined dramatically in conjunction with the reduction of suitable sagebrush habitats due to anthropogenic impacts and climate change. And these declines got so bad that they were even considered for federal listing under the Endangered Species Act, which motivated broad-scale, multi-million-dollar state and federally sponsored management plans. But if we can use the Homestead record to determine what things affect sage grouse populations, so vegetation, temperature, precipitation, seasonality, what factors cause sage grouse to be pushed out of an area, and then what's needed for them to come back, this information would be really useful to be able to figure out how to best conserve this species now and going forward with future climate change. So for instance, across the time period that we just looked at, if we now focus on terrestrial records, we know from the paleovegetation and small mammal records from Homestead Cave that at the beginning of this sequence, there were thick stands of sagebrush around Homestead Cave. But then around the time of stratum 2, it was becoming drier, and big sagebrush stands were thinned and became mixed with other more xeric shrubs such as shadscale, greasewood, and horsebrush. And then by stratum 4, it was warm and dry in the basin, and sagebrush stands were largely replaced by those xeric shrubs. So from this other evidence, I predicted that the sage grouse record should roughly follow the pattern of sagebrush. So sage grouse should be abundant in the Homestead record in stratum 1, and then they should decrease noticeably, if not disappear completely, by the time we get to stratum 4 and stratum 5. And that is what I found. So there is a slight decline here between stratum 1 and stratum 2 when the sagebrush was becoming a little bit thinned. But then there's this huge, significant decrease in the relative abundance of sage grouse in the homestead record, right at the time when sagebrush largely disappears. So this record, the homestead record, can be used to determine the relationships between greater sage grouse populations and various environmental factors. And I'm in the process right now of using a paleoclimatic record that was developed for this area in the basin to see how different climatic variables like temperature, precipitation, and seasonality affected sage grouse in the past, which will be especially useful in developing management strategies in light of current climate change, including being able to identify areas that would be conducive to successful reintroduction efforts. And this is not just limited to greater sage grouse and the other taxa that I discussed. So once the entirety of the homestead record is established, it will be the longest, most fine-grained and well-dated avifaunal record in North America. And thus far, Homestead Cave contains records of at least 75 different bird species, including many regionally important species whose continued existence is crucial to the preservation of the unique Great Salt Lake ecosystem, along with other taxa that have received a lot of conservation attention locally, such as the snowy plover and yellow-billed cuckoo. And this is extremely valuable for modern bird conservation because it greatly extends the records that we have for many of these taxa. So armed with these 13,000-year records, we can increase our ability to forecast how avifauna will vary. Oh, sorry, the dog didn't like that. We can increase our ability to forecast how avifauna will vary in the future with environmental changes, unlike any we've seen in historic times, and thus improve our conservation strategies so that we can maintain a landscape with birds, as Howard Stansbury described almost 200 years ago, as far as the eye could reach. Oop. That's all I have. Thank you. And sorry about my dogs barking in the middle of that.
So what are your dogs' names?
They have kind of funny names. So I have Tortuga, who goes by Tuga, and Zodia, who goes by Zori. So I have a turtle and a skunk in Spanish.
Awesome. It's one thing about Zoom I love is meeting people's pets. It's great. Okay, I have like a million questions for you, Allison. I'm gonna like try to hold off until the end, but I do want to ask you, like, how like you get this project, and did you just have like a bunch of owl pellets put on your desk, or how? I mean, like, what do you do? Like, what are the logistics of this? Because this is 13,000 years of bird records, and
yeah,
like, how did it come to you? What's it like?
Yeah, that's a great question. So it's actually the whole homestead collection is curated at the Natural History Museum in Salt Lake there. And so somebody else, a woman named Stephanie Livingston, actually did the initial analysis of the bird bones for Homestead, and it was published in the original monograph that was published about Homestead Cave. But she did not get a chance to look at everything and identify everything. So there was a lot of stuff. It's just literally Ziploc bags on bags of bones. So the owl pellets have disintegrated a bit, although some of the bones still have like a little bit of residue on them. But because they were spit up by owls, the preservation is fantastic. Like they're, compared to other archaeological bones that you might encounter, there are whole bones. They're like in really great shape. I didn't calculate how much, like the percentage wise I could identify, but for each stratum, I usually end up with just like a tiny little bag of things that I couldn't identify. It's really a fantastic collection for being able to research birds, where it's like there are thousands of bones per stratum. So sample size, which is a huge issue in doing archaeological work, sample size is fantastic. Preservation is great. So what I'm looking at logistically when I get it is just bags of bones. it's like Christmas.
My mind is like I can't even imagine. And I'm hoping that Kayla Martin, she's one of my students who's listening, she might give you a call, Allison, because
Oh,
she's
of course.
going to be identifying some bird bones from the tar seeps that get entrapped in the Roselle tar seeps. And so Kayla, make sure to hook up with Allison.
Yes, please do.
Okay, I have so many questions, but I'm gonna hold off until the end. So
All right.
thank you, Allison, so
Thank
much.
you.
Well, now we do have one more panelist, but I always love to share stories because I've spent a lot of time working out at Great Salt Lake, and this particular story happened many, many years ago, and has to do with people, the humans that use Great Salt Lake for her resources and rely on this lake. And it's a pretty unbelievable story. It's about 7 minutes long. So if you need to go to the bathroom, or if you need to go get another drink, please go do it right now. This is a story that I told at the Bee. It's a lovingly competitive storytelling competition with Juliana Serena. And this actually played on the 2016 Pioneer Day special. I can't tell the story again like I did this night when we were at the Leonardo, and there were a few hundred people, and they wanted to talk about Great Salt Lake, Small Lake City, and have people tell very short stories about their experience. And so I got to share this story. And after this, we will talk to Dr. Chris Merritt. So go to the bathroom, get a drink, listen to my story, whatever you want.
To tell you my story. And this is a story that happened with the Tooele Police Department. They called me one day on my cell phone, and this is kind of how the conversation went. Hello? Hello, is this Jamie Butler? Yes. This is Tooele Police Department. I don't have a very good Tooele Police Department voice. You're gonna have to, this is my Tooele Police Department hand. This is Tooele Police Department. We're investigating something. Can you tell me why you might be associated with Great Salt Lake? Well, officer, I work there and I hang out there a lot. You see, in my 17 years of working at Great Salt Lake, one of my jobs was a wine delivery biologist. That was kind of my unofficial title that just happened. It was under other duties as assigned by my friends. Really, my job was a sea monkey biologist. I got paid to go around Great Salt Lake in a boat and count brine shrimp. Anyway, these friends of mine, these brine shrimp friends of mine were brine shrimp cowboys, and they were here. They would spend weeks at a time in the middle of Great Salt Lake on their annual brine shrimp cyst roundup. These little cysts, they were in the water. The brine shrimp released these little minuscule time capsules every fall right before they die in the cold winter months. These little cysts, they hatch and grow and reproduce and repopulate the lake in the spring. It also turns out they're really great fish food and they cost a lot of money. So maybe you could hand me or give me a little yip if you're really excited to know how many brine shrimp are in Great Salt Lake. Oh, that's so warm and welcoming. So it turns out that in the high of the heat of the summer, these brine shrimp, their population densities are so big that the biomass of brine shrimp in Great Salt Lake is equal to the biomass of 1.8 million people. That's half of the population of Utah in Great Salt Lake. Crazy. So the conversation continues, right? Are you okay? Is anything the matter? Oh, wrong hand. Let me start over. Are you okay? Is anything the matter? No, officer, everything's just fine. I'm fine. I don't think anything's the matter. Thinking, I'm talking to Willow Police Department right now. That's really weird. Okay, thank you, ma'am. Wait. No, what is this in regards to? Ma'am, we were dredging a harbor and we found partial human remains. Now, I don't know if you know this, but Great Salt Lake isn't really a great place to get rid of things. You see, it's so salty that things that are alive or dead, they just float. They float to the surface in the dense, salty waters. I've come to think of this salt as as a memory, Great Salt Lake's memories. You see, 22,000 square miles of water empties into this closed basin that's in our backyard. And those things stay there, except for water that evaporates. Everything else stays there and it concentrates. Officer, how did you get my phone number? Well, you see, during our investigation, we walked the shorelines. Have you been to Great Salt Lake? Tell me again. Yep, if you've been to Great Salt Lake. The shorelines are really weird and unique. And sometimes they're really cool. And sometimes you want to get naked and you want to roll around in the cool, white, soft sand. And other times you look around and you see thousands of dead birds scattered around you. And they're pickled and preserved in the salty, dry sand of Great Salt Lake. And I know it sounds really weird, but I look around at those dead birds and I think about how cool it is. And it shows me how much life is in Great Salt Lake. If you were a biologist, someday, if you were a biologist, you might go out there and you would count the birds. And you would count 7 to 10 million birds represented by 257 species that come to Great Salt Lake specifically for Great Salt Lake. And imagine all the other stuff, the things that eat the birds and the things that eat the things that eat the birds. It's pretty incredible. Officer, I'm still a little bit confused as to how you got my cell phone number. Are you still there? Ma'am, when we walked the shorelines, we found a bottle. And when we took the cork out of the bottle had your name in it and your phone number. My name was in a bottle, a message in a bottle? You're kidding me, officer. Was it a wine bottle? Thank you, ma'am. Click. He couldn't wait to get off the phone with me. Anyway, it turns out my brine shrimp cowboy friends, they were replacing all the wine in those wine bottles with my name and phone number. And it was part of a scientific study, they said, and to call me if they found this bottle. And so Officer so-and-so from Tooele Police, he did. A few years later, I ran into a man, totally happenstance, here in Salt Lake, who used to be part of Tooele Police Department. And I recounted this story thinking that he would shrug and he would blow me off and whatever. But he didn't. He smiled and he laughed and he took my arm and he said, Jamie, that body was 400 years old. That was the torso of a Native American woman. Can you imagine? Sometimes I joke I was mistaken for a 400-year-old dead body. Anyway, so I think of this woman a lot. I imagine her to be out earning her living and providing for her family in the place that she was born and loved. I imagine her to be taking advantage of the crazy abundance of life that is Great Salt Lake and is our valley, just like I do. And this 400-year-old, this body that was there for 400 years, she was preserved in the memories of our watershed, just like the our actions that we take right now are going to be preserved in all of the water and the sediment at Great Salt Lake.
That really happened to me. Can you believe that? And it really connected me to the people that were here before we were. And I think that that's very special. And so I'm really excited to have Dr. Chris Merritt here today to talk about some of those people. Chris received his PhD from the University of Montana in anthropology in 2010. He focused on the archaeological and historical investigations of the overseas Chinese. Before that, he received a Master's of Science in Industrial Archaeology from Michigan Technological University, where he studied the trade and consumption of Mormon-produced pottery in Utah. Since 2004, Chris has worked in a variety of professional archaeological settings, including the U.S. Forest Service in Utah, Nevada, private archaeological contracting in Salt Lake, and finally now with the State Historic Preservation Office, where he is working with state history in the Utah Division of State History. He also works with college students, where he's an adjunct faculty in anthropology at the Salt Lake Community College. And I hope, Chris, I'm so glad you're here. Dr. Judson Finley from Utah State University had to cancel kind of last minute, and Chris just stepped right in. Judson did receive an NSF grant recently to study the Fremont people that lived in the Great Basin, and so we will bug him again and hear from him, but thank you. Thank you so much, Chris, for coming, and I hope you have like something to say about my cheesy story that I just told. You can make fun of me.
I would never think of doing that. No, thank you, Jamie, and I appreciate everybody showing up tonight. I couldn't leave Jamie hanging with Judson, unfortunately having to bail. So I did whip up a PowerPoint to kind of put this in perspective, the Native American relationship to Great Salt Lake. And so while I started this at 4 o'clock this afternoon, I was able to pull it out my butt, which is an opioid or opiate or whatever Jack said, the doctorate in geology. He knows a lot more than me. So
it goes along with our like theme of old crap. You know, usually Chris talks about old crap at these things and I talk about bird crap. So pulling it out of your bum, that's perfect.
Well, and I love, Jack's talking about brine shrimp poo and Allison's talking about bird vomit. It feels like we're in the right flow right now. So thank you, Jamie. So to put it in context, so where Jamie's story kind of intersected with the prehistoric Native Americans of Great Salt Lake, our office is involved in that. And so when those human remains were discovered, our office actually did respond once they were determined to be ancient Native American human remains. We have a program that during those discoveries, we respond to recover, and then we work with the tribes to repatriate those remains. But I want to circle back to that story because we sometimes think of this European elitist, like, well, the lake existed once Stansbury wrote about it, once Bonneville wrote about it. Like, well, people have been using this lake a lot longer than that and the marshlands around it. So I really appreciate both presentations before me. And so I want to quickly kind of move through this Native American contribution to the story and kind of put our lives in context to this broader and deeper story. So in archaeology, we divide human cultures into categories. We're Western thinkers, so we got to put people in boxes. And so you had the video that Jamie played with Anya Kitterman from Hill Air Force Base, and she talked about this site. And this is the first arrival of humans into North America, is what we call the Paleo-Indian period, the first peoples. And depending on where you land in the archaeological literature, these folks are from Northern Asia. They migrate across the Bering Land Bridge or move by boat along the coast, either through a northern route or a southern route. But we know by 20,000 years ago, humans are in North America. And then Utah, we're getting more and more information every day. And this information is coming out of Great Salt Lake and its environments, because this was such a massive freshwater lake when the humans first started encountering this landscape. And you saw by Allison's talk, lots of fish even in this landscape and birds. It was a great draw for humans very early. And just a few years ago, just 5 years ago, we hit this hearth out on the testing range. And Air Force does a great job of stewarding their cultural resources. And so they did an archaeological excavation to recover this eroding fire hearth, this campfire. And there was lots of bird in there. And the radiocarbon dates is the tool that we use to date things. Showed that it's 12,800 years old, this hearth. So this is like some of the very first humans, very first Native Americans to arrive in our state along the marshlands and the freshwater areas of the Great Salt Lake. And the point that the man is holding there on the left of the photo, that's a Clovis point. That is some of the oldest types of projectile points that you get in North America. And that was just sitting in this dry lake playa. Now, Paleo-Indians, they were the ultimate nomads, the ultimate hunter. These guys were the ones out there, guys and gals, out there hunting mammoths. They're out there hunting rhinos. They're hunting megafauna that were existing in North America at this time. And they focused on those big animal species for most of their food. And because of low population numbers, and it was cooler and wetter, we're coming out of the ice age, it was, a nice little cool existence. But as we move into about 9,000 to 10,000 years ago, North America's climate started changing along with the rest of the world. And we move into an area of human history we call the Archaic period. Now, the Archaic period is really exemplified by a drier and warming climate. And the megafauna died. Multiple theories on why the megafauna died out, why mammoths went extinct, climate change factored in, hunting factored in, disease factored in. But those big animal species that people were targeting now disappeared. So humans adapted, as we always do. And so the people in this period were still what we would call nomadic or semi-nomadic, meaning they're constantly moving to follow plants and animals. But during this Archaic period, we see an expansion of the food they're targeting. We also see the arrival of new technology to extract that food. So we see the arrival of grinding stones, and you've heard of manos and matates, those big grinding stones with mano in your hand, the matate is the flat tablet, and they're grinding seed, they're grinding grains, and they're grinding even insects that wash up in windrows on Great Salt Lake. We see the arrival of nets, yes, fishing nets, but also rabbit nets to catch, big herds of jackrabbits, that communal hunting behavior that we knew about in the Paleo-Indian period, but now it's being used on smaller species like deer and antelope and elk and jackrabbits. If you were out in the Great Plains, it'd be buffalo hunting in these big factors. Atlatl technology also arrived. So an atlatl is a spear thrower. And so it's an additional tool. I'll show you in the next photo how this functions. But we're well before bows and arrows. We're at the period we're still chucking spears. The atlatl gave us higher velocity and better accuracy with these spear points. And so that gave the hunters an edge on the prey. We also see the arrival of basketry, weaving reeds and bulrushes into basketry. Sage, all this stuff is being used during this Archaic period. So as we kind of cruise around the lake, one of the most famous excavations in the Great Basin is this Hoggup Cave. It's still on private land, but it was excavated professionally by archaeologists after permission of the landowner way back in the 60s. And much like Allison talked about, it's a deep layered cave. There was well over 13 cultural levels excavated, with the oldest being about 8,000 years old. So, 6,000 BC-ish. So this gave us this huge run of human history. And from it, we see this atlatl. And so you can see the object that was recovered there on the right, and you can see how it would have functioned, kind of attaching to your finger and then the back end of the spear, and then giving you that really nice leverage to throw a spear at long distance and high accuracy. They found moccasins made from different types of leather and cordage, brush and weeds. We saw rabbit nets again being found. We also found tons and tons of plant and animal species from the hunting and gathering behavior. Now we see pickleweed. Pickleweed shows up in every single site in the Great Basin that is around these sort of saline environments. Now, there's multiple ways you can use it. And Native American groups like the Goshu, who were interviewed much later in time, said that they would use those really high protein and oily seeds as a little diet, and they bake them into cakes with nuts and berries to improve the flavor. Maybe throw some insects in there too, make like a pemmican, if you know that term from old fur trapper days. The pickleweed was really incredibly important, but also used in medicinal purposes. They found mats made from sagebrush at Hoggup, so for sleeping, but some actually had dried human blood in them. And so they thought that maybe these sagebrush mats were actually being used as menstrual pads for women at this period. But we don't know for sure, but some evidence. And Hoggup did recover one domesticated dog. And so we know that humans have been working closely with canines for a long time, much like Allison's dogs wanted to participate in her talk. We used dogs to carry burdens before horses in North America. They also could have been consumed as food if times were hard enough, but we did find a domestic dog at Hoggup. But these things together tell us a really cohesive story of what the archaic period looked like. In Hoggup Cave, it's a very austere environment. There's not a lot of fresh water out on the west end of the Great Salt Lake today, but back then there was a little bit more fresh water, a little bit more vegetation, a little bit more wildlife. And so these artifacts, much like Allison's talk, give us that reconstruction of past environments that helps us better understand our place in the world. Moving a little further south, probably everybody's heard of Danger and Jukebox Caves over by Wendover. These are managed by state parks. And this is a really cool drawing that one of our former state archaeologists put together, but showing this layering of human activity at the mouth of Danger Cave. And you can see at the bottom, we're talking Clovis era, we're talking first Paleo-Indian periods, all the way up to World War II and post-World War II use of the cave for probably not occupational purposes, but hanging out. But these layers tell us the different stories. And almost in every layer, we see pickleweed, we see Indian rice grass, we see native plants being used for cordage and basketry and moccasins, and just this very symbiotic relationship between native peoples and the lake's resources and then the marshes surrounding it. And if you drive to Wendover today and look at this cave, it's really hard to conceive of a very lush, nice location to go camp and stay. But that's really what we were looking at, 9,000, 10,000 years ago out at Wendover. As we move out of the archaic, things start getting a little bit better. It's a little bit wetter. It's not as hot as it used to be in the archaic. And so out of the south, out of Mexico, through New Mexico, Arizona, through San Juan County today and upwards, was the arrival of agriculture into this part of North America. And during this period, we call it the formative. And the formative is this, about 2,000 years ago, maybe a little touch more, to about 700 to 600 years ago. And this is when we see the first arrival of agriculture, agriculture meaning people intentionally planting and maintaining plant species for human consumption or use. And we see the Fremont is the most indicative culture here in Utah. It's actually Utah's sort of unique cultural group. Doesn't really exist very far into Idaho, very far into Nevada, doesn't really go very far into Colorado. So it's kind of Utah's unique cultural tradition during this period of Native American growth. And it was really indicated by agriculture, people living in places much longer. They established villages and home sites. Some of the biggest home sites and villages down in I-70, go to Fremont Indian State Park and Museum, Five Finger Ridge, which was excavated before the construction of I-70, just this huge sprawling, almost metropolitan farming community on these hills overlooking their fields. Population of Native Americans increased during this period because agriculture allows for more population than a nomadic lifestyle like Archaic or Paleo-Indian period. We see the arrival of pottery during this period. Now, up here in northern Utah, our pottery tradition isn't quite as well developed as what you would see down in San Juan County, Blanding, or Bears Ears. We didn't get quite that high level, but there was trade and interaction. We found stuff manufactured in southern Utah on sites in northern Utah. There was a large trade and exchange system going on. In northern Utah, we had a ton of obsidian. We had a ton of salt. that other parts of the Great Basin didn't have access to. So, some tribes were trading those for shell beads or pottery. And so it was a very much more expansive human history. And so we see the points getting smaller and smaller. So we have, the Clovis points, which are big as my hand. The archaic points, you get elkos and haskets. By the time we get to the former period, we're seeing bow and arrow technology. We're seeing the arrival about 500 AD, about 1500 years ago, of the bow and arrow in North America, which revolutionized hunting behavior. And so points could be smaller. You didn't have to be worrying about those big points to take down critters. And corn. Corn was the focus of the agriculturalists here, but we do have beans and squash being produced throughout northern Utah. Now, this very badly drawn map is showing you Fremont villages in concentrations on the margins of the eastern shore and the southern shore of the Great Salt Lake. Now, these are there because of those nice big freshwater rivers, the Bear, the Weaver, the Ogden, and the Jordan, all flowing towards Great Salt Lake, but also really great farmland, lots of fresh water. We know the Fremont were building early ditches and canals to bring water to marginal lands. And these are the people that really populated northern Utah, Native American speaking, in our history. Now, the person that Jamie was mistaken for, this 400-year-old woman, which I can see the resemblance, I get it. She was found in that southern shore. And during one of those great, lake up, lake down seasonalities, there was actually several dozen sets of human remains pulled out of this marshland around Great Salt Lake during the 1990s and early 2000s. Lots of human remains. People are buried everywhere. The Fremont in particular didn't have formal cemeteries, so you would be typically buried near where you died, if not underneath your own house. And where these marshes were so critically important, a lot of people were buried in this tidal zone of marshland to lake. And so during this high period, we recovered several dozen sets of human remains of Fremont peoples. And we're working still to try to get these back to the tribes for reburial. But this just gives you an image of how big the Fremont culture was. And it was in northern Utah. Great Salt Lake and the Wasatch was the focus. It even wraps down into Grantsville and Tooele. We have Fremont villages north and south of Great Salt Lake, all speaking to this very big tradition. Now, one of the coolest sites on Promontory Point, a lot of folks get that confused on the Transcontinental Railroad that was closed on Promontory Summit. On Promontory Point, we have a series of caves, the Promontory Cave Network, and there's several down there. Archaeologists work, these are again on private land. And this is one of these late, that has some archaic components, but it really was famous for the picture on the left. And it had over 230 moccasins recovered from the excavations. And people have called it the Walmart of northern Utah. Well, these moccasins were left there for hundreds of years, if not decades. They were deposited because you would be walking all this distance. It was before the horse. So these moccasins would wear out a lot. A lot of these moccasins showed where you'd stop in this cave overlooking Great Salt Lake, maybe hunt, maybe do a little freshwater fishing over at the Bear River, what's now the Bear River Refuge, and then replace your moccasin. So it just slowly deposited. But the Promontory Caves are just cool because it gives us this late formative experience of Great Salt Lake. And then things changed. So we know that in the 1300s and 1400s AD, so 600 to 700 years ago, the climate shuddered a little bit. We got a little bit drier, we got hotter again. And so when you're an agricultural community, your entire life is really dedicated to growing crops, supplementing from hunting and gathering, but that was your focus. When the climate got a little hotter and drier, suddenly your seasonal harvest got a little bit less consistent. And so you could have a couple good years and a couple bad years. And this is what happened to the Fremont and also what we used to call the Anasazi. Now the appropriate term is the ancestral Puebloans down in San Juan County in the Four Corners area. As this climate shift occurred, farming was less suitable. Things kind of got dicey. People started fighting more for water and resources, and the populations kind of dispersed and collapsed in certain areas because agriculture was no longer tenable. And much like the biological concept of carrying capacity, your environment can only sustain so many people. And if agriculture is failing, you go back to a different mode of life. And so from that 1300 AD to 1400 AD, the Fremont kind of just evaporated. Now, a lot of people call them the vanished culture. They didn't vanish. They just went back to a nomadic hunter-gatherer lifestyle. They abandoned their village life, and they've become, part of modern tribes we know today, like the ancestral Puebloan tribes of, the Zuni and the Hopi and some of these folks in the Southwest. They didn't disappear. They just went back to an older lifestyle. Well, right about the same time, about 500 AD, we see this movement of what we call Numic speakers. And these are folks that speak a Numic language. So these are folks coming out of the northern part of the United States or Western Canada, maybe parts of Western, like California. And they started moving into this area because of the void left by the Fremont. And we see these Numic speakers are tribes we recognize today as the Goshute, Shoshone, the Paiute, and the Ute. And so we start seeing these new tribes moving into these areas and starting to exploit these same resources that people did before. And this is when 1846, you got the Donner Party wandering through. They're interacting with these tribes, and then a year later, the LDS folks that arrive. That's when we see the reshaping of the Great Basin again, with first permanent European and American settlements. These tribes all interacted with Great Salt Lake, whether directly or indirectly. Many Goshute elders have been interviewed, and they're like, yeah, I remember the elders telling us about gathering the huge waves of Mormon crickets that died and got sucked into the Great Salt Lake, and then they blew up, and they're all nicely already salted and pickled, so you could have a snack, but you could also pull all the arms and legs off, grind them into a little patty, and they would even sell these to some of the early LDS immigrants who were also on hard times. They were in a marginal desert environment, much like the Fremont. And so they were also struggling with agriculture at the same time, but with more developed agricultural tools like canals and much more expansive technology. But I do want to leave with this is we get caught in this Western phrase of, well, the natives are gone, or these areas have been abandoned, or even these sites are abandoned. To most Native people, these sites, like this rock imagery panel out on Stansbury Island, Stansbury Island, Antelope Island, all have rock imagery from Native Americans on them, spanning archaic all the way up to Numic-speaking folks. These are still part of an active culture. They are not abandoned in a Western sense like a ghost town. The stories are still there. Those places still have meaning to the tribes. And so one of the things I like to always leave people with is, while you don't see these big villages of Native Americans no longer on Great Salt Lake, the food, the places, the meaning of Great Salt Lake are still part of these tribes. And we should be respecting these images of the past as we start thinking about the long time stewardship of Great Salt Lake, because they've had a much deeper relationship with this lake than we ever have or ever will. So there's a brief little synopsis of the archaeological history of Great Salt Lake. Hopefully that was somewhat interesting. Thank you, Jamie, for the invitation. And you don't really look like a 400-year-old woman. So.
Oh, thank you. Yeah, and I was struck by your slide where you had like the image of like where people were living, Tooele and like along the Wasatch Front, because really that's what we're doing now, right? We kind of settled in these same places. And I really love Dr. Brent Olson is somebody that I've worked with at Westminster, and he calls Great Salt Lake a place of movement and transformation. And so thinking about what Jack Oviatt has talked about with water levels and like these transformations and movements of water. And also Allison, she's a doctor soon, Dr. Allison talked about this place of movement and transformation for birds also, depending on water levels and salinity. And then humans that not just, maybe over a time scale stayed here and relied on resources, but also within the year I've heard, you know, stories about them moving kind of vertically through our environment from Great Salt Lake up into the mountains. And so I think we have this just amazing, cool place. So I would invite Jack and Allison and everybody to turn your videos on and for all of our people to ask questions. This is our question session, and we have a whole 10 minutes to ask questions. Allison, I know this one was for you. Have there been any similar long-range historical studies made at Sevier Lake in order to compare with the Great Salt Lake?
Possibly, not that I've heard of, not that I know of, and actually in the area, the best comparative records are actually some of the archaeological sites. So like Chris talked about Danger Cave, for example, and Hog Up Cave. It's a little bit shorter record, but those both have really long records that have some birds in them. Especially greater sage grouse, waterfowl that people were eating. Bonneville Estates Rock Shelter is another one, kind of out near Danger Cave. But other than that, Homestead is one of the like prime records of its kind in the basin or in the West. There are other comparable paleontological records. I know like in the Snake River Basin in Idaho, a couple sites out there that haven't been widely reported on. But yeah, but in the Bonneville Basin, the best records are some of the archaeological records.
I wonder if Jack could comment on the Sevier Basin relative to the Bonneville Basin and ages and so forth, and the relationship based on that question.
Well, yeah, well, I can't really say anything about the bird paleontology. I don't know much about that, but as far as, yeah, Sevier Lake probably behaved very similar to the behavior of Great Salt Lake, at least in historic time. Although not a whole lot of work has been done on Sevier Lake, so we don't know precisely, but in the prehistoric past, again, we just don't have much information to go on. So, but it's likely that Sevier Lake was behaving pretty similar to the way Great Salt Lake was behaving, as you know, as far as lake level going up and down in response to climate, because the climate in the Sevier Basin really isn't very different than the climate in the Great Salt Lake Basin. So that's sort of a non-answer.
No, that's helpful. It's nice to think about the landscape in addition to the people and the animals.
Yeah.
Mm-hmm.
Any more questions? This is a quiet crowd. I think everybody's excited to like get outside and hang out, go do field work, count birds, count brine shrimp. Any more questions? So Chris just put, remember we're putting some links in the chat. Chris just put a link about more of the Fremont and a video that you can check out. I had a million questions and I forgot all of them. I should have asked you like right away. I was too excited about how your research came, Allison, like in baggies.
I had a question about the sage grouse and what their range is like today. I know they are in parts of Utah, but I don't know. Like I was actually kind of excited to hear that they were closer to the lake. So where are they today, Allison?
Yeah, actually, if you give me a second, I actually just made a map of this today. Let's see. There we go. Do you see that?
Yeah, wow.
Oh, that's not what I wanted. Yeah, so this is their modern range today. Their historic range is a little bit wider around these edges, but they're now restricted to 11 states in the US and 2 Canadian provinces up here. But yeah, so this one doesn't have Great Salt Lake in there, but Great Salt Lake is about right here. So Homestead is about right here, if you can see my mouse even, but it's right here. So historically, there are records of greater sage grouse in the lakeside range where Homestead is. They're a little bit sketchy. So I don't know how true that is. They could have been other species of grouse that these early explorers were seeing. So like huge grain of salt, but they don't occur anywhere near Homestead Cave today.
Allison, I had a question too. You talked about kind of the plant life, during the same time periods and the fish life. I mean, is everything categorized in Ziploc baggies where how do you know what the plant life was 13,000 years ago?
Yeah, so the fish records that I talked about all came from Homestead Cave. And that was actually my advisor, Jack Broughton, who's at University of Utah. He analyzed the fish remains from Homestead Cave. And then there's also a really good small mammal record from Homestead Cave that his advisor, Don Grayson, who's at University of Washington, that he analyzed. So we know a lot about vegetation from the small mammal record because there are a lot of small mammals that are obligates to different kinds of vegetation. But there's also a really good vegetation record in the Bonneville Basin from both, there are pollen records from cores out of Great Salt Lake, and there's also a really good record from wood rat middens, so like pack rats. There are a lot of dry caves in the West in general, but in the Bonneville Basin, there are a lot of dry cave sites where pack rats would make their nests. And when they make nests, they bring in all sorts of different twigs and leaves and all kinds of plant parts to build their nest. And then they'll pee and poop on them, which kind of solidifies them and fossilizes them and preserves them. So we have pack rat middens in the Bonneville Basin that go back tens of thousands of years, that contain like huge parts of plants that are easily identified. We call them like macro vegetation, like macro remains, that you don't need a microscope. You can just look at a leaf and be like, oh, I know like what plant that comes from. So we have a really good pack rat midden record from the basin, which gives us a good idea of vegetation through time, along with the pollen and the small mammals.
It's so cool. I called this Back to the Future because I really wanted to connect our past with our future, because I think, the work that all of you all are doing and all of you talk to us about are really doing that. We're saying like this environment changes a lot, and we kind of have to change with that. Like the example that Chris gave of, people moving out because it just wasn't a good place for them to live. The Fremont left. And so I really wanted to highlight that and really want people to think about the past as being an indicator for the future. I do love that we talked about a lot of pee and throw up, and Chris even talked about, how Indians might have taken care of their menstruation problems. I think that is a really, really, really awesome way to end this program.
Becky Menlove, who just recently retired from the Natural History Museum of Utah, has an invitation to come see exhibits about Homestead Cave.
And really, you should. I took my daughter up to the Natural History Museum, and it is a phenomenal place to go. I mean, there were hardly any people there. I still am a little bit nervous about people because I haven't been around anybody for a year. Go to the Natural History Museum. Thank you, Becky. It's a really awesome place. Well, good. With that, it is exactly 8:59. We didn't even go over. We're exactly on time. I want to thank you for coming. Pay attention to emails. We will start Salty Science series and the Salty Shorts back up in the fall. We're going to go have a good summer, and we're going to be outside, and we're going to travel, and we're going to be around humans and maybe hug some people, and decompress from this pretty incredible year. So thank you, Jack. Thank you, Chris. Thank you, Allison, for being here and sharing your enthusiasm and your expertise. You know, let me know, everybody in the audience, let me know if you need anything, and just have a really awesome time. I'm going to stop the recording.